When adding liquidity to liquidity pool, ideally we want the price to stay the same, which means the liquidity must be added at the same ratio as the reserve ratio. Now, how can we incentivize the users to add liquidity at the reserve ratio? In Uniswap v2, it's done through a punishment mechanism. Basically, it means if you don't add liquidity at the reserve ratio, you will be punished with less LP tokens. Inside of the mint function of Uniswap v2 pair contract, we can see this line of code. This is the code that handles the dirty work. We can see here the code is comparing this part and this part and take the smaller one to calculate liquidity. But since both parts have this element total supply, we can take it out. So essentially it's comparing this part and this part and take the smaller one to calculate the liquidity. And by the way, the liquidity here is the LP tokens that the users can get. Apparently any user would want to maximize the liquidity here. Now let's use math symbols for simple demonstration. Let's say the liquidity pool has two tokens, token A with a reserve of X, token B with a reserve Y. Now a user called Alice adds some liquidity. Let's say he add token A with $X, token B with $Y. Now according to the code here, we need to compare these two values, which essentially are $X divided by X and $Y divided by Y. We all know that when you compare two values, there can only be three cases. Let's examine them one by one. Case 1, $X1 divided by X equals $Y1 divided by Y. In this case, we can transform the equation to this. This means the user is adding liquidity at reserve ratio, which won't change the current price and should not be punished. We can use either side of the equation to calculate the LP tokens. In case 2, $X2 divided by X is greater and $Y2 divided by Y. We can transform the equation to this one. This means the user is providing liquidity at a greater ratio than the reserve ratio, so it will change the price and should be punished. And how do we punish them? We can see here, since the right side of the equation is smaller than the left side, so the LP tokens will be calculated according to this value. Now imagine the user reduced the token A to delta x 2 prime, where it divided by x is equal to delta y to divided by y. And in this case, the user will still get the LP tokens calculated according to this value, which is equal to this value. In this case, the user can get the same LP tokens, but saved this amount of token A. In another perspective, if a user provides liquidity at a ratio that is greater than the reserve ratio, he or she will be punished with this amount of token A. Any rational person will not want to be punished real money for nothing. So this will incentivize users to not provide liquidity at a ratio that is greater than the reserve ratio. In case 3, when the user is providing liquidity at a smaller ratio than current reserve ratio, same logic, he or she will be punished with this amount of token B. Finally, to sum up, this line of code ensures a rational person will provide liquidity at exactly the reserve ratio by punishing these two cases. Okay, that's all for this demonstration. Thanks for watching.